Okay, let's do a little right triangle trig review. Let's start by drawing a right triangle and labeling our sides X, Y, and R. We know there's a relationship between those sides, and that comes up again and again in calculus, so we should make sure we remember it. X squared plus Y squared equals R squared. We're going to save that for now, but don't let it get too far away. All right, the next thing we need to remember is about similar triangles. So two triangles are similar if they share exactly the same angle measurements. So if that, I have right triangles in this particular case, but they don't have to be right triangles. So if this angle matches with that angle, this angle matches with this angle, and the third angle matches the third angle. If that's the case, then the triangles are similar. It does not require their lengths to be the same. And by the looks of my picture, they're not. So this is X, this is Y, this is R. We could call this X prime, Y prime, R prime. Okay? Now, again, the sides are not the same length in similar triangles, but because their angles are, the ratio of their sides are the same. So what that means is Y is to X as Y prime is to X prime. Y is to R as Y prime is to R prime. And X is to R as X prime is to R prime. These ratios are so important that we actually give them names. So let's look at my right triangle again. Let's let the focus hit us, which will happen now. Okay. Label our sides X, Y, and R, and we'll call this the angle theta that's associated with this particular triangle. Okay, so again, I want to talk about those ratios we talked about a minute ago, and so we're going to talk about this one, Y over R, so this side over this side, we're going to call the sine of theta. Okay, this side over this side, X over R, we're going to call the cosine of theta. And lastly, Y over X, we're going to call the tangent of theta. Remember that theta wasn't relative to the lengths of the sides. It was the ratio that changed from different triangle to different triangle. If I were to draw a similar triangle to this one, so I knew that angle was also theta, and this was X prime, Y prime, R prime, well, that ratio would be the same as this ratio. So Y prime over R prime is also sine of theta. It's related to the angle theta and not the lengths of the sides. Okay, now I don't want you to get caught up on particular variable names, so let's find a way to talk about the lengths of those sides relative to their position with respect to theta. So let's have our right triangle again with that angle theta, and this time let's call this side right here the one that is adjacent to theta, or next to theta. This one right here is the side that is opposite to theta, and this one we'll call the hypotenuse. Okay, so now we can talk about those ratios relative to these new names. So the sine of theta is going to be equal to this side over this side, or opposite over hypotenuse. The cosine of theta is equal to this side over this side, or adjacent over hypotenuse. And then the tangent of theta is equal to this side over this side, or opposite over adjacent. All right, this is going to be important to remember as well. Let's look at one quick example. Let's look at our familiar 3, 4, 5 triangle. Not really drawn to scale. And there's my angle theta. So let's talk about the ratios given this very specific triangle. The sine of theta, remember, is opposite over hypotenuse, or 4/5. The cosine of theta is this one over this one, adjacent over hypotenuse, or 3/5. And then the tangent of theta is this side over this side, opposite over adjacent, or 4/3. All right, So this right triangle trig is the building blocks to what is to come.